Hello, welcome back. In this segment, I will talk about another rule related to implies. It's called the rule implies introduction. I will introduce this with an example. Let's say we have P and Q implies R as a premise. Let's take the theorem prover assistant we have, and I will prove this. Along the way, I will introduce you to the notion of rule implies. It's P and Q implies R. P and Q implies R is the premise, and the conclusion is P implies Q implies R. So this is the conclusion we need to arrive. So I will put a bracket so that it's not confused. Okay, now we need to start thinking about the proof. So the premise is P and Q implies R. So what we do is we look at the right hand side. We have first P. That means we will make a new subproof, right, for P as an assumption. And then we create another subproof because we have a Q here, over here. So we create another subproof Q. Okay. We have P and Q. Okay, we can introduce and. So this is the and introduction, right? In lines 2 and 3, we can introduce and. Okay, what we can do now is, if you look at the premise, right, P and Q implies R, so we get R. So this is because of the elimination of implies, if you want to call that way. We are going to eliminate implies. Line number 1 and 4. Because 1 says P and Q implies R, and we do know P and Q happened in line number 4. Therefore, we can combine 1 and 4 to get R. Okay. And now it's important to watch out. We started with the assumption Q and we arrive at R. We should put Q implies R, okay, on a new line. The question is, should the new line be directly under the Q proof or is it above? Okay, let me show you what I mean by that. Suppose I say Q implies R now. Okay, let me say this is where I'm introducing the implies, right? This is the implies introduction from line numbers 3 through 5. See whether our proof is meaningful so far. Let's check the proof. Okay, you can see line number 6 cites an unavailables of proof 3, 5. The reason why it is wrong at line number 6 is that from Q we arrived at R. The meaning of this is only if Q is true, we are able to arrive R. That's what we are claiming if I put it like this. Okay, that means I should put it one level up. Okay, let me delete this and add a new line one level up to the parent of this. And now I should be able to safely conclude Q implies R. Now I'm introducing the implies rule through line number 3 and 5. Implies introduction through line number 3 and 5. Okay. Now it should be free of errors. Let's check that. Hopefully it goes away. Oh, no. Cites too many. Oh, I made a mistake here. I should say 3 through 5 reasoning. Okay. Yeah, very good. So far, everything seems to be working fine. If we assume P and Q, we are able to show Q implies R. Okay. And now we can also reason about the same from outside of this Q box. Okay. From P, we are able to arrive at Q to R. That means if we can add one more line to the parent of the P, we can now conclude P implies Q implies R. Okay. So we are introducing implies through line numbers 2 to 6. So this should work out well, hopefully. Yeah, the proof is correct. Congratulations, message came. So as you can see, I have introduced 2 layers of subproofs. First layer is for assuming P to be true. Second layer assuming Q to be true. And the important thing to notice that from Q, we are able to arrive at R, but then we need to mention that one level up. That's the reason I was able to mention it one level up. Because independent of whether Q is true or not, Q implies R holds true because we just proved that. If Q is true, we can arrive at R. If Q is false, by the fact that you start with something false, you can always arrive at any conclusion you want. That's the reason we are pulling it up one level. The same reasoning holds true from P, we were able to arrive to Q implies R, so I can pull it up to the parent of P. Okay, that's the reason I have one line up. Okay, so this is an interesting proof that we have 2 sub boxes. We also achieved the goal of explaining the notion of introducing implies. Okay, that's another fundamental rule in the rule of deduction. Okay, So now I will formalize this for a more generic case. So we proved it. We successfully convinced ourselves this is true. So you start with some general premise pi, okay, and you apply all the proof rules or whatever proof rules that you like to arrive at, say, another premise psi. In the literature, usually people put a box, although on the tool we put a line, a vertical line, and we divide it further down to each sub box. Okay, so in this case, we start with pi, we arrive at psi. That means we can say pi implies psi. This rule is denoted by an arrow mark, which is implies, and I, introduction. So implies is introduced by this fashion. You start with pi, you arrive at psi. That's why you call it implies introduced. All right, that's all. Thank you very much for your attention.